We have the ability to perform ingress and egress anti-spoofing with access control lists. Now, let me tell you, that's a lot of work. I've had the opportunity, not saying it's a great opportunity, but I've had the opportunity to configure both ingress and egress anti-spoofing access control lists. So what are these? Well, an ingress anti-spoofing access control list is designed to prevent external networks from sending spoofed traffic into your network. That's the whole premise behind it. So if we look at this configuration down here, you'll see that they have an access control list configured that is denying IP traffic sourced from 10.1.1.0 through 10.1.1.255 going to any destination, and we're logging it. So what this is doing is it's making sure that packets that are sourced from 10.1.1.0 network coming inbound are denied. Now, why do we want to do that? Well, think about where 10.1.1.0/24 is right now. Where is it? Yeah, it's over here. It's way over here. So should traffic ever be sourced from 10.1.1.0/24 if it's coming from the internet? No, not at all. So we are going to make sure that nobody can spoof an IP address we're using inside of our network from an external place, an external source, and spoof that so they can gain entry into our network. Another example here is that they're spoofing, or pardon me, not spoofing, but preventing or denying the entire 127 range of addresses. So that way that can be used as a spoofing mechanism as well. But then they're going to permit IP traffic from any source going to 10.1.1.0/24. So it's okay if the source address is something else and the destination is 10.1.1.0, that's fine. It's going to be allowed through this interface. But if the source is 10.1.1.0 arriving on this interface, then we have to deny that to prevent spoofing from happening. It's just simply creating access control lists based on your topology and your diagram to try and figure out, okay, which way is traffic flowing? If traffic's flowing this way, then it should never be sourced with this particular IP address. So let's deny it at that point in time. Now, the egress anti-spoofing is done to prevent a network from sending spoofed traffic to other networks. So what we want to make sure of is that the users inside of our network are not allowed to spoof. For example, use an IP address on the internet or an IP address in another network as they're sending traffic out of their network. So what we're doing down here is we're saying, all right, we're only going to permit traffic that's sourced from 10.1.1.0 going to any destination outbound on this particular interface. Now, in addition to that, this could have been applied on this interface as well. It could have been applied inbound on the interface, and by applying it inbound, even though it's inbound, it's still classified as egress anti-spoofing because we are preventing our internal users from spoofing traffic as they're going out of their network. That's the whole concept behind this. But if you think about your networks and you think about all the different subnets you have deployed and all the different little functions, services, and features you have, this can become a very complicated process. So instead, we can use a feature known as Unicast reverse path forwarding. So this is a feature that's going to allow our router to automatically check the source IP address of every single packet. And it's going to compare that source IP address to the forwarding information base. So this process of Unicast reverse path forwarding is going to rely on Cisco Express forwarding. Now, how does it work? Well, it can work in many different ways. We can use strict Unicast reverse path forwarding, loose Unicast reverse path forwarding, and VRF mode. But regardless of the mode you're using, what is your router trying to do? Your router is trying to verify that the source address of the packet is accurate, is correct. Now, how does it do that? Well, let's take traffic flowing this way. Here's what's going to occur. With strict Unicast reverse path forwarding, our router is going to make sure that there is a valid entry in the routing table on top of making sure that the packet arrived on the interface that would be used by the router if it had to send traffic to that IP address. So in this case, we just had a packet arrive inbound on gigabit 0/1, source 10.1.1, destination 10.2.3.4. So the router checks the forwarding information base and says, okay, what entry do I have in my routing table for 10.1.1.1? I would have this entry. So it's not doing this for forwarding purposes, it's doing this for the check. So there it is. Now, if I was to have to send a packet to 10.1.1.1, what interface would I use? I would use gig 01. Now, did that packet arrive inbound on gig 01? If it did, then Unicast reverse path forwarding checks out and everything is okay. However, if it didn't arrive inbound on this interface, because it's strict URPF, then the packet's going to be dropped. It's not allowed through the network. Now, what about loose Unicast reverse path forwarding? Well, let's follow the same path. With loose Unicast reverse path forwarding, the router simply checks to make sure that there's an entry in the routing table for that source address. So the packet comes in gigabit 0/1, and with loose URPF, it says, all right, do I have an entry in the routing table that I could use to reach the network that the source address is listed as in that packet? And if it says yes, great, perfect, forward it. So it doesn't check to see if the interface also matches. It just checks to make sure it has an entry for the network of that source IP address in the routing table. That's it. That's all. So strict is much more strict because it's verifying the network and the interface, whereas loose is just verifying the network. Now with VRF mode is going to allow the router to check based on the different virtual routing and forwarding tables that you have on the router. You see, VRF allows you to create these virtual routing tables for potentially different customers that you have when you're using MPLS as an example, and BGP, multi-protocol BGP, VPNs. So what can we do here? What we can do is we can set up VRF mode so that way there we have the ability to check based on the individual VRFs as opposed to our normal global forwarding information base. So here's a nice chart that sums up all three of these: strict URPF versus loose URPF versus VRF URPF. And you'll notice here that when it comes to step 1, it's all the same. All the same. Step 2, though, is where we start to find the differences. In step 2, with strict, remember it's checking both the network as well as the interface against the source IP address, whereas with loose, we're only checking what? Just the network. And with VRF URPF, only the network as well. For step 3, if it's found, allow it to go through. If it's not, we have to drop it.